Now, since you asked earlier, and since it's worth checking this as well, let's also check an alternative justification. So an alternative to checking ends is the second derivative test. I do not recommend the second derivative test. I try my best when I give you problems to make it really hard to apply the second derivative test. But in this example, the function is simple enough so that it's perfectly okay. If you take the derivative here, remember, this was whatever it was, 2x minus 4v over x squared. If I take the second derivative, it's 2 plus 8v over x cubed. And that's positive. So this thing is concave up. And that's consistent with its being the critical point is a min. Is a minimum point. See, now I almost said is a min as opposed to minimum point. So watch out. Yes?
So is this the answer to the problem, or would you have to give y and y in terms of a?
You're one step ahead of me. The question is this the answer to the question, or would we have to give y and a and so on and so forth? So again, I want to, this is something that I want to emphasize and take my time with right now, because it depends what kind of real-life problem you're answering, what kind of answer is appropriate. So far, we've found the critical point. We haven't found the critical value. We haven't found the dimensions of the box. Okay? So we're going to spend a little bit more time on this exactly in order to address these questions. So first of all, the value of y. So far we have x is 2 to the 1/3, v to the 1/3. And certainly if you're going to build the box, you also want to know what the y value is. The y value is going to be, let's see, well, it's v over x squared, so that's v divided by 2 to the 1/3, v to the 1/3 squared, which comes out to be 2 to the minus 2/3, v to the 1/3. Okay? So there's the y value. On top of that, we could figure out the value of a. All right? So that's also a perfectly reasonable part of the answer. Depending on what one is interested in, you might care how much money it's going to cost you to build this box, this optimal box. And so you plug in the value of a. So a, let's see, is up here. It's x squared plus 4v over x. So that's going to be 2 to the 1/3 v to the 1/3 squared plus 4v divided by 2 to the 1/3 v to the 1/3. All right? And if you work that all out, what you get turns out to be 3 times 2 to the 1/3 v to the 2/3. All right? So if you like, one way of answering this question is these three things. That would be the minimum point corresponding to the graph. That would be the answer to this question.